Good morning, teachers. It's 6:21, June 12th of 2024. The date won't matter that much. This is one of those podcast videos where I talk to the teachers whose work has already brought them into the matrix of people who traffic in this particular curriculum set of memes to which I can contribute. It's not like this is, quote, my curriculum. It's one that I do my best to feed into given my position as a computer teacher. Now, what's my experience? Just briefly, if you're tuning in for the first time, who am I? What am I talking about? I go by Kirby Erner as a name. He, her. Sorry, he, him. And I've got this Oregon Curriculum Network going, have had for decades, that I fund as a private business. So, like, I'm a for-profit business, and as a hobby, you could say, I do this curriculum development work, which can bring me income. There's nothing to say it can't. But I sort of think of it as a nonprofit off to the side. But I haven't gone to the trouble to make it a 501c3. People don't give me charitable donations like that for tax deductions, that is. It's just, a face to the world, a public face. And it's gone through many incarnations, you could say, in terms of websites. And in terms of how I've presented myself. I've talked to geographical institutes. I've talked to a lot of computer conferences, talked with a lot of classroom teachers. So I do the local stuff. Saturday Academy, kids. I work at different age levels. Coding with Kids is on my resume. That's a fairly new company. Started in Seattle, and I helped really get it going in Portland by, being the gray-haired veteran of computers, that is, who, I used to train older folks in their 50s. Now I'm in my 60s. So I go way back as a computer trainer, but also as a math teacher in the grade school level, so high school, middle school. And that goes way back. That goes back to Jersey City after I got out of Princeton. Taught high school there in Jersey City for a couple of years, but much more recently as well. Like just during the COVID pandemic, as we were coming out of that, one of the little schools, a private school, needed somebody to fill in after a teacher got COVID, and my name had spread by word of mouth in that community, and so as a pinch hitter, I got hired. There wasn't really the understanding that I was getting a permanent job there or anything. It was just, can you finish this 8th grade level course? Now I say 8th grade, but it was really quite accelerated. It was their star students looking at high school and wanting to excel, wanting to be. They had one guy that they thought of as the main genius of their school, and the other kids really looked up to him. And so I had that kind of dynamic going. It was challenging for any teacher, not in a bad way, but in a good way, positively challenging. And so I'm just saying, I have classroom experience and I work with teachers, and I'm fairly integrated. Let's say going back also, I worked in what we call, you could say as a lobbyist in a way. Talking after I worked at McGraw-Hill, after I was a textbook editor, not on staff, contract guy. I worked in getting more discrete math accepted in the legislature so that a student going through high school, if they don't want to take calculus, but they're still really into math, they just want to go a different route, maybe through group theory, number theory. They could do that and then maybe pick up calculus later in college when they decide if they're going to need it then, right? And get it from a physics teacher. Different ways to get calculus. I like it embedded in physics because that's kind of where it was born, why it was created, how it really shines. It comes with its application right away instead of purely abstract calculus, which I also have looked at, through Spivak under Thurston at Princeton. We did a really, I would say, other end of the spectrum, much more abstract approach to linear algebra as well. But I'm into hands-on, and I'm especially into using computers as part of everyday K through 12, and not just Desmos, not just sort of applications, but also learning to code, actually writing code as part of math class, you see. Because calculators, I think, have gotten in the way and stopped our advance. And I think we're kind of, okay, where I entered this whole scene as a little kid was Sputnik. By that, it's kind of code when I say that. What I really mean is the new math, which was in some part a panic attack here in the U.S. when Sputnik went out and around. This is a Russian satellite, first one, like one of the first satellites ever, made a beeping noise, at least stereotypically. You can go back and study the period, but there was like kind of a, oh my gosh, we're falling behind, our kids aren't going to be able to compete. In the coming decades, we better reform our math and science really quick, because that's where we're weak. That was the perception. And University of Chicago had a lot to do with the response. Lots written about it. I'm somewhat well versed, but I would not say, I'd say find other podcasts that go into more depth about, like SMSG it was called, some other things. New Math, basically. Tom Lehrer's New Math song is, I highly recommend it. Because he was a math teacher, and the song is mathematically correct. The lyrics sing you through a subtraction problem, but also in base 8, and we were learning in these different bases. That's what I remember as a little kid, is before we left for Italy, like even in the second grade, they were helping us understand about positional notation, like why we put something in the so-called tens place. Tens place, hundreds place, we're learning that our decimal system is kind of tallying up how many of these different powers of 10. And to help us get that, it's like it makes a lot of sense even in that early grades to say, well, it doesn't have to be 10, this base, right? Instead of tallying up tens, hundreds, thousands, let's tally up twos, fours, and eights and stuff, powers of 2. Powers of 3, powers of 4. So we were learning that pretty early. I've encountered skeptics who said, no, second grade would be too early to have any talk on bases. I don't know about the textbooks themselves, but I know the teacher. I can remember the chalkboard. Anyway, we went to third grade, but I went to third grade after that in Italy, junior English school. And I was taken into a whole different culture. It's still math, it's still Anglophone. We're still speaking English after a fashion, but it's different curriculum and with its own advantages, its own strong points and weak points. And then I shifted gears again, and I think going back to a more Americanized school, but still in Italy, I think my switching channels, seeing different curriculums, and when I got to Princeton, going into reading rooms where I could read, different textbooks that I had never encountered, and, for high schools I had never gone to, what did they learn about this and that topic? I looked up, in American high schools, what do they say about Marxism, if anything, in their textbooks? And it would often be a paragraph in there, something like, you may find these ideas strange. And it's like, we have to study them because a lot of people believe this stuff, but you and I, wink, wink, we know it's crap. That would be the way that a textbook author could get Marxism into a textbook that's going to go somewhere very anti-communist. It's like, you're teaching communists in the schools, communism. But then you have to say, well, yeah, we want your kids to know what's going on in the world. Like, even if they're not going to be communists, they better know who Marx was and maybe something about what he thought and so on, like that. So you just make the writing clear to parents. Really, textbooks have a lot to do with the parents. They want to see their kids getting the right stuff, and they have a strong idea of what the right stuff is, especially if they're what they consider themselves to be successful. Like, I'm a professional, I'm a dentist, I'm a doctor, I'm a lawyer. I know what I needed to do to get to this point. I know what math I use on the job as an engineer, if I am, or a computer guy. I'm not saying parents shouldn't be interested in this. I'm a parent. I was a parent. I'm still a parent. And I take great interest. Here I am talking about curriculum, so I'm not denigrating the parental role. Instead, I'm saying textbooks have to appeal to the parents. Okay, so this is all pretty bland, you're thinking. This is like, okay, you get the ecosystem, you see that I stand for some fairly banal things like more computer programming, less emphasis on calculators in K through 12. Okay. You've probably heard that before. If you're in professional teaching sphere, that's a very known sort of position. So where do I differentiate myself? What makes my curriculum more interesting, let's say? How do I compete with the big, especially open source curricula out there? Free open source, that's one of my trademarks coming out of Portland. Free open source capital, according to Christian Science Monitor, or aspiring there to be that. That was way back in 2005 or something. OSCON's always come here, Open Source Convention, which is organized by the O'Reilly Publishing Company. They do the animal books, so-called animals etchings on the cover, very classic collection, and computer topics inside. I think they ran low on animals, given so many computer topics out there, so we got some vegetables and stuff. I worked for O'Reilly full-time as a teacher for a small school. An experimental O'Reilly School of Technology got off the ground there with me as one of the faculty. So I wasn't hands-on involved in the conference organizing, except, I kind of take that back, I was on the program committee a few years and got to read hundreds and hundreds of proposals of people wanting to talk at OSCON. The deal there is if your talk got accepted, you got free tuition. So it was nice. You got, it's not like your hotel got paid for, your airplane, but you didn't have to pay the daily fee and your meals were taken care of because so on at the conference. Anyway, that wasn't the only reason you want to talk, but it was a perk, right? You want to promote your reputation, your company's ideas. There's lots of reasons to give talks at OSCON, and I gave at least a couple. PyCon is another one I traveled around in. So this curriculum that I've developed here, you may remember if you've been around a while, but for many decades, especially 60s, 70s, and then he died in 1983, this guy Buckminster Fuller, right? We called him a futurist. And I was not my whole life a super Bucky fan. And I've only become more of a Bucky fan after he passed away in 1983. That's when I started to really dive in more. Actually, before that, right? So I started teaching at this school in Jersey City, and I was a geometry teacher then and a calculus teacher. some world history, right? It was a very small school, so the teachers were multitasking, you could say. And I was getting into Bucky right there after Princeton. I'd just done, a whole bunch of academic work, philosophy included. I was sort of primed to keep thinking along those lines. Like I wasn't going to grad school, but I wasn't switching off my scholarly side. And so even as I was teaching, I was diving deeper into synergetic geometry, which is what Bucky Fuller called his explorations in, quote, the geometry of thinking, unquote, which in itself is a very interesting tagline. And the content proved very philosophical. And I had been a philosophy major at Princeton, so the continuity there was very strong. There's even more to that story that made it a strong segue into synergetics from Princeton philosophy for me in particular. And I realized the math content in particular was accessible to high schoolers, middle schoolers even. Like the innovations here would be fine to include in K through 12. And so at the time, Synergetics was a fairly new book, and there wasn't a lot of indication that it wouldn't migrate into that role. Like, was I going to ride a wave or was I going to fight an uphill battle? At that time, it was still unclear. It looked like I was going to ride a wave, maybe. Like a lot of us were going to embrace this material as somehow worthy of inclusion. Maybe not in the standard math track, maybe electives on the side, maybe not in just every school, maybe pilot here and there. And I started doing my pilots. How do we get the Bucky stuff in K through 12, especially in high school? Let's just focus there. Like, what would be a smooth way to include this material? But again, when the questions first started occurring to me, it wasn't like, am I going to be the only one doing this? It was more like, where are my peers and how are we going to do this? Let's use the internet to organize, because the internet was fairly new at that point for ordinary people. So we're talking again, 80s, moving into the 90s, World Wide Web. And I do find peers. Like there are a lot of teachers, but most of them not in the classroom, especially not just high school teachers. Certainly not with philosophy degrees. It's like there may be PhDs though, right? Doctor of philosophy, but we're eliminating vast amounts of people here because we're talking about something not in the curriculum. And when you think about it, it's not easy at all to budge the curriculum, the high school curriculum. It's already bought and paid for by the time it gets to the end user. Big processes have gone through, big wheels have turned, millions of dollars at stake. And like I say, I'd been at McGraw-Hill, and I knew that it was going to be next to impossible to do any direct rewrites of textbooks or something like this. It's going to have to be an organic process, and I was just waiting to see what the shape of that would be. Now, when I say including this Bucky materials, what am I talking about? Am I just talking about futurism, modeling the future, Club of Rome, climate change, lots of lines going up and down, kind of like when you go in the hospital yourself and there's all these like rhythms and heartbeats and all that kind of stuff on the screen. So, getting those measures for the Earth, and we've been doing that, right? This is something that we're all familiar with, like dashboards. During the COVID pandemic, we had a lot of dashboards. So visualization of global data is not a new idea. And that was part of what Fuller was into as a futurist. He was really into getting a lot of big data together and visualizing and analyzing and data science and all the kind of stuff that we're really into, right? So he was anticipatory in that way. He was in line with where things were going in that way. However, he also innovated in some new ways, and just to get to the sort of bottom line in his geometrical thinking, he was seeing in nature a lot more use of like 60-degree and 120-degree angles. Whereas humans are so rectilinear, what really stands out about our thinking, our architecture, the shapes of what we build on land, especially less so in the air or at sea, but on land, we're really into rectilinear XYZ coordinates, kind of like right angles, we call them. We say normal, meaning right. If you're into the jargon of math, you know that a normal vector is like right angles to something. Normal, right. The orthodoxy, even orthonormal, means at 90 degrees. It's like we're imbued in a culture that's very imbued with rectilinear thinking. And that works fine on an XY plane, but then, of course, the Earth being a sphere, latitude, longitude, you get these trapezoids that get really thin as you get to the poles. I'm just saying there's a conflict sometimes between our fixation on squares and the application, what we're trying to do. We might be better off with, say, hexagons or pentagons or a mix. So what we do in the Bucky world is basically take the cube, which is the root of all right-angled thinking, you could say, and swap it out for a regular tetrahedron as kind of our anchoring shape. It's the unit edge, unit volume tetrahedron that's going to take the throne, you could say. Will be the captain of our new geometry as opposed to the unit edged, unit volume hexahedron of 6 faces, 6 square faces. We're going to go for 4 triangular faces. It's simpler, but it is still a container, unarguably, right? It's got, you could say, an inside and an outside. We want to start with something that has an inside and an outside. And if you're looking down on a circle on a plane, you're still looking down. There's like this altitude down to the circle you're looking at. There's separation between observer and observed. There's always space between what you're imagining and yourself, you could say. Phenomenologically, we're very anchored in a sort of spatial beginning. So we're not, even though we can find like linear tracks and planar surfaces in this space, we're not inclined to think that there is such a thing that we have to imagine as one dimension, just all by itself. At the very least, we have phenomenologically, experientially, three-dimensional space, except if we're going to start there and not go below that. Like I say, you can go below that in your imagination. You can imagine the square world of Edwin Abbott Flatland. But you'll notice you're not flat yourself. You're still in space when you think about Flatland. And so starting in space, we're going to say the tetrahedron is our beginning, not the cube, and it really implies, you can see it as an arrowhead almost. Floating tetrahedron is like pointing in 4 directions, 4 corners, 4 faces, very 4. And XYZ, we argue that's 3-dimensional because, well, we take 3 orthonormal or mutually orthogonal perpendicular number lines and intersect them, X, Y, Z, and there's 3 of them. And if they weren't at 90 degrees, if they were zigzag, it would still create space, right? So I like to think of doing a Zorro sign, kind of like zigzag, where you're making the sign of the Z and then reverse the Z. It's like, I did a search lately, is there a Unicode character that's the opposite of Z? You could do an N and a Z, but think of them as slightly unfurled or out of a plane. In other words, when you do a zigzag, do like an angle, that's going to be in a plane. No matter how you draw it, you're going to draw a to B, B to C, and then when you go C to D, get off the plane that you just created. When you did A to B, B to C, now sort of go up like a spiral staircase. Start up the spiral. You've done your floor, now start up. You've got all your dimensions, in other words, your so-called 3 dimensions. You could say to yourself, height, width, depth, as you draw these little Z's, and as soon as you've drawn one, the other one appears, the complementary one is going to be there. In other words, when you draw 4 non-coplanar points, you can draw them without lifting your pen by doing stroke, 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 and there's your first Z, but your second Z is already there, or is created at the same time. That's kind of where 3 dimensions enters, is with stroke, 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 making a Z. But we're going to say, alternatively, in a different jargon or namespace, a different shop talk, we're going to take that dimension of 3D and we're going to say 4D, and we're not going to mean 3D plus time, and we're not going to mean another orthogonal, 3 plus 1, another orthogonal, in a spatial sense, which would be what we call extended Euclidean, or we could call it just ordinary linear algebra continues with the orthogonals, with all these caveats about how we can't really imagine them, and if we could only see in 4 dimensions, and some people maybe can, and all that. There's a whole, like, if I'm a chatbot, I can follow this, like, very predictable set of paragraphs at this point about how difficult it is to see in higher dimensions, and then we can have thousands of dimensions and so on. That's what I'll call linear algebra namespace. Very useful. It works. Can't say it's broken. Any of these. Einstein 4D plus is 3D plus time. You could say, and then you can sort of rotate your coordinate system in time space, get more time, less space, and vice versa. The Minkowski space and so on. And then I'm saying there's a third namespace or shop top that we've decided not to share with students. So it did become an uphill battle, not a tsunami, right? I didn't ride the wave. I found that no, teachers are not going to want to talk like this. It's too contrarian, too maverick to talk about 4 dimensions in this yet another sense. That of the tetrahedron being 4-dimensional, 4-faced. The beginning of volume is a tetrahedron. Let's call it 4D. No, that's not going to ring. That's not going to propagate. And I think because the way the mind works, right? It's either or the way we think. It's like, well, if I teach that, I have to give up the 3D stuff. And they're not going to get into college. They won't do any. They'll mess up the SAT. It's like if we go to 4D and Fuller's unit volume tetrahedron, what happens to their test scores? And it's not like that, in my view. It's like, yeah, we need to keep teaching the traditional, conventional math because that's where all our eggs are in that basket mostly. But in the history section of our curriculum, or in intellectual ideas, or like futurism could even be a topic in your school. There's all these different ways to get into the curriculum, this alternative shop talk that does use the math terms, use the math language, and that gets us to the heart of a kind of a philosophical question, which is this allowed? Can we do this? Can individuals sort of go off on their own in terms of what they mean by X, Y, or Z, gravity, radiation? Because this is what Fuller does. He writes a whole philosophy where all the words have a different spin. Like, it's not that he invents new words so much, is that he's in his own namespace and the words mean what they mean relative to each other. And in a way, this is a very mathematical way to think, is that we have sort of these free floating, sort of membrane, balloony kind of things with their own axioms and their own consequences, their own theorems internally there too. And they have fibrous interconnections to one another, these many mathematical blobs or whatever. It's like I'm giving you a sort of a mental picture of what's already the case for some people when they think about sort of math as sort of a set of namespaces which have their own integrity. They do rely on each other somewhat for, and there's historical tracing how one gives rise to another and so on, but the synergetics with the unit volume tetrahedron and the way that it talks and sets up concepts can kind of blend in there as one more sort of thought balloon, so to speak. And it can float in the history of ideas where we talk about American futurism and bright futurism. In other words, here's the punchline. It's very dangerous, in my view, to take one of the main futurists used, and I lived overseas, as you've heard. I saw Bucky's stuff being used sort of for PR purposes. Expo 67, there was this big giant Taj Mahal, he called it, dome that had the U.S. pavilion for Expo 67. The whole idea of geodesic domes had sort of grabbed the imagination of the world as symbolic of a positive shared future that we, the planet, would have, spaceship Earth and so forth. So you take a very positive futurist who's integral to the country's PR, you could say, and then make this decision to not include the very interesting, innovative, non-orthonormal geometry that he comes up with and publishes. You decide to make it an uphill battle instead for people like me to have that be part of what's in the schools. And so where do I go with that now? Having fought the uphill battle, we've got the materials. There's no reason to not use those materials. And I'm seeing, international schools and so on, going back to Sputnik and New Math and stuff. There may be another sense coming of needing to catch up, like having fallen behind, not having a good futurism, not having a plan for the planet. What was your vision? How were you going to make things work? And we can say, well, if you're on the Bucky bandwagon, here's how. And you've got a lot of artifacts, inventions, visions of the future, positive things that could be done, all linked to this very interesting geometry. Now you throw that out and you are left with what? In other words, how does your curriculum broadcast that this culture has got something positive in store for the world? In contrast to some kind of, endless wars or whatever. So there's where we bridge to general systems theory higher up in the curriculum or further along in the curriculum. And I've got all kinds of analysis, again, that takes you forward in terms of energy budget, Markov chains. These days, active inference getting into it as well. Speaking of Markov, that one being the Markov's blanket. Anyway, on into college, right? So we need to get back on track with this. And the decision that the boomers made, because I didn't really understand Bucky that well, I have to say, as far as this math goes, right? They picked up on the dome, but when it comes to like the T and the E modules, you've heard me talk about this in other videos, the little tetrahedral wedges and stuff, they just tuned that out. It wasn't of interest. So they threw out this opportunity for continuity, and now we have to compensate for that in some of these schools that we're we're going to get on board with this material because the advantages are so obvious. When you start to include it, you get a lot of history, you get Marshall McLuhan, you get all kinds of thinkers, Black Mountain College, Kenneth Nelson, all kinds of culture comes flooding in, and you get to be an elite school all of a sudden that has inside knowledge of all kinds of culture. Like it goes with the territory. To once you start covering this stuff, you become a more elite and a better school. People look up to you because wow, you're tackling that. We're still in the Stone Age, right? Still using calculators. So I've got synergetics mixed in with the Python, all the unit volume tetrahedron stuff, the concentric hierarchy, check Wikipedia, check Quadrays. It's all there, and boomers who chose to not go with this are retiring and leaving a lot of vacancies as they go. So what I'm suggesting is we continue this process of filling the void with something that could have already been mainstream and take that attitude. It was just a choice that the boomers made to not do the work, except for like I did the work and friends of mine were working on this. It's not like none of the boomers picked it up, but on the whole, as a generation, the boomers didn't want to do this work. So let's get on it. Let's catch up. Let's try to get back in the saddle, as they say, and own up to our own history. I'm not saying throw out any big chunks of stuff. Just remember to adapt to a world that's changing, right? We can't always be in a rut and teach the same stuff year after year as history goes on. It doesn't stop, right? It's not like we can just sort of sit back and say, well, that's it. History's over. Now it's just, I don't know what. I don't know what was expected. I don't know what the other side wanted to happen, but it's not going to go that way, I don't think. All right, we're going to have a world where we have more Bucky. That can't be all bad. So let's get down to work. And if you have more questions on those slides or any of that, if you're choosing to use those, I'll be getting back to them. Don't worry. Explaining more of the nuances. I've added a few slides here and there and so on. All right. Talk to you. Some of you will be on Zoom calls and we'll be in correspondence. Talk to you soon.